All right, Algebra 2 guys, this is factoring. Just want to take a quick note that factoring, basically what you're doing is you're trying to take something that is complicated and make it into simpler pieces, okay? So the main way you talk about factoring is this. You're trying to break apart a number or an expression and writing it as a product of its factors. So product obviously means multiplication. So if you're going to look at the number 20, breaking it down to the prime factorization means breaking it down to nothing but prime numbers. So if I'm looking at this mathematical expression, 15a squared b cubed, well, 15 broken down to prime factorization is just 3 times 5. Then a squared is a times a, and b cubed is b times b times b. Okay, that would be just the basic factorization of either a number or an expression. What we're looking at is trying to factor trinomials and trying to factor quadratics. So if I look at kind of the factor puzzles, this whole thing is just trying to get you in the mindset of breaking apart numbers into common factors. So the way you do this is by looking at this. So if I look at 12 and 15, what's in common? What's the biggest number in common there? Well, that's going to be 3. If I look at 8 and 12, what's the biggest number in common there? Well, that's going to be 4. All right, so now I got to think. What times 4 gives me 8? Well, that's going to be 2. What times 3 gives me 15? Well, that's going to be 5. So I put 2 and 5 there. So which means 10 goes in there because 5 times 2 is going to be 10. So if I jump down to number 4, what's in common between 15 and 35? 5. What's in common between 15 and 18? 3. So now, plain and fill in the blanks. 3 times what gives me 18? I'm going to look down here now. That's going to be 6. 5 times what gives me 35? That's going to be 7. So 7 times 6 is going to give me 42. So if I jump over here to number 5, 32 and 40, that's going to be 8. 45 and 40, that is going to be 5. So 8, 8, 5, 5. 5 times 9 gives me 45. 8 times 4 gives me 32. So 9 times 4, this is going to be 36. All right, so if I do this number 3 quick, so 4 and 4, 12 and 15. Here is going to be 3. So 4 times 2 gives me 8. 15 times 5. If 3 times 5 gives me 15, so 10 should go right here. All right, that's kind of all I'm asking you to do for that. So the big types of factoring we talk about are this. Greatest common factor, that's GCF. Trinomials with just x squared. Trinomials if there's a number in front of x squared. And grouping. Grouping, the thing you got to remember about this is when there's 4 terms, that's when you want to do grouping. So GCF factoring, pretty straightforward. What's in common? Pull that out, write what you have left. All right, so 12x minus 36, well, between, if I really want to think about this, 12 would be 2 times 2 times 3 times x. 36 would be, let's see, that would be 9 and 4, so 3 times 3 times 2 times 2. All right, it's just, you don't have to do this every single time, but it's not a bad habit to realize kind of what you're doing in the bigger sense. So what's the most in common? Well, you've got 2 2's here, 2 2's here, a 3 here, a 3 here. So what's in common is 2 times 2 times 3, which is going to be 12. So that's what I put on the outside. Then on the inside, I put what's left. Well, I've got an x here, and I've got a 3 here. So there is my factored form. And again, you don't have to break it apart that far, but I just want to see kind of what you're doing. So 39, that's going to be 3 times 13 times x plus 13 times x. So what's in common? Well, 13 is in common, x is in common. So if I pull out 13x, I write what's left, 3x plus, since there's nothing left over here, I put 1. So that is how you factor. So here you can start to get good enough where you can just recognize what's in common there. Well, you see there's an x in common, you see there's an 8 in common. So I'm going to pull out 8x, and I'm going to be left with just x plus 2. Good way to check, if I distribute this back through, I better get this. Otherwise, I did it wrong. All right? So a good way to check is if I distribute it, what am I going to get? So here, that's going to be 5x squared, because 5 is the biggest thing in common with the numbers. X squared is the highest exponent. So that's going to be x to the 5th minus 4x plus 8. That's factored out by greatest common factor. And again, the way I check with all of them, if I distributed this, would I get what I originally started with? Remember, you're working backwards. Okay, so when they're in trinomial form like this, you are basically unfoiling. And the way I like to think about it is this, okay? When you're factoring this, one of 4 things is going to happen, okay? You're either going to have x squared plus bx plus c, x squared minus bx plus c, x squared minus bx minus c, x squared plus bx minus c. And I split them apart for a reason. This kind of tells you how to do it. If this is plus, the second sign is addition, that means that both my answers are going to have the same sign. Okay, so both my answers are either going to be x plus something or x minus something. Well, Mr. Heeren, how do you know which is which? Well, that's easy. You look at this sign. All right, that sign tells you what it is. So if the second sign's addition, my signs are the same in my answer, and the first sign tells you what it is. So if I look at number 11 here, x squared plus 6x plus 8, that's plus plus. I know my answer has got to be plus plus. So now how do I figure out what goes where? Well, here's where I kind of work backwards. Look at number 8. What multiplies to 8 but adds up to 6? So I got to start thinking, factors of 8. What factors of 8 multiply to 8 add up to 6? Well, 4 and 2. So that's going to be just 4 and 2. Likewise here, addition, addition. My answer is going to be x plus, x plus. So that's going to be x squared plus 13x plus 12. Factors of 12 that add up to 13. So that's going to be 12 and 1. So that's just what I write here. Number 13 is a little bit different. You see how I've got negative there. Negative or subtraction there implies one of them is going to be addition, one of them is going to be subtraction. All right, whenever that second sign is subtraction, I'm going to have different signs down below. So now I also think about it a little bit differently. I also think about what multiplies to 4. But now, instead of having addition here, I want to think about what subtracts to 3. So what multiplies to 4 but subtracts to 3? Well, 4 and 1. 4 times 1 gives me 4. 4 minus 1 gives me 3. But how do I know which goes where down here? Well, this sign goes with the bigger number. So if it's plus 3, that means it needs to be plus the bigger number, which is 4. Okay, so if this second sign subtraction, I have one of each. This sign goes with the bigger number. So one kind of special case, and if you think about it, here's kind of what's happening. Think about it as x squared minus 0x minus 4 instead of just x squared minus 4. It's like there's no 0 term. Well, if I follow the rules, what multiplies to 4 but subtracts to 0? Well, 2 and 2. All right? This is subtraction. So that tells me I have one of each. All right? So in this case, with this situation, it's just the same number in there. Okay? So this is just going to be like x squared minus 0x minus 64. Well, what multiplies to 64 but subtracts to 0? Well, that's going to be 8 and 8. So that's just going to be x plus 8, x minus 8. This one, number 16, is just going to be x plus 5, x minus 5. The key to this is recognizing when a number is squared. So what happens when I put a number in front of x squared? Well, this gets a little bit hairier. This is kind of the big one, so you got to pay attention. Here's what I need to do. First off, take first times last. So take 2 times 5. And that gives me 10. I want factors of 10 that now add up, I'm still keeping with this sign, to 11. All right? Now, my rules don't change here, okay? That's plus, that's addition. That means my answer is going to both be addition. But now, because there's a 2x in front, I don't know. One of these is going to have an x. One of these is going to have a 2x. But I don't know which one's going to be which. Okay? So I don't know that yet. So I can leave it as x, but I got to realize that there's going to be a 2 in front of them, in front of one of them somewhere. So here's what I want to do. Factors of 10 that add up to 11. Well, that's easy. That's 10 and 1. Here's what I want to do. I want to rewrite the middle term using my factors. So I want to rewrite 11 into 10 and 1. Now I did this for a reason. Now I want to group them. All right, to break it into 4 terms and group them. So 2x squared and 10x. If I pull out what's in common there, find the greatest common factor, that's going to be 2x, left with x plus 1. Nothing in common, oh sorry, x plus 5, my fault, plus x plus 5. There's nothing in common there. Well, this is like having a 1 out in front of it. So what my factors become are 2x plus 1 and x plus 5. So my solution here is 2x plus 1 and x plus 5. That's my answer. Okay, but the big point is multiply this, figure out factors of that number, rewrite it, and then group it. So now this gets a little messier because there's a minus there. Okay, so I got to realize that in my answer, one of them is going to be plus, one of them is going to be minus. But I still follow the same rules. 3 times 7 is 21. Well, multiplies to 21, but now subtracts to 4. Well, 7 and 3. Now I need to rewrite negative 4 using 7 and 3. So I go 3x squared minus 7x plus 3x minus 7. So I rewrote negative 4 is negative 7 plus 3. And anytime this is a minus right here, that's subtraction, you're going to have to do that. One of them is going to have to be subtraction, one of them is going to have to be an addition. So now if I group this again, I'm going to get x plus 1 and 3x minus 7. Now, another way you can do that I think is pretty useful, it kind of organizes it for me. From this step, instead of grouping, you know, I've had situations where I've put it into a box like this. I put each term in a separate box. Then I go greatest common factor, greatest common factor, greatest common factor, greatest common factor. I go across, cross, down, down. So greatest common factor here will just be x. Greatest common factor here will be 1. Going down, 3x squared and 3x is going to be 3x. Minus 7x minus 7 will be minus 7. So that'll give me those same 2 factors. Again, either way, both of them take a little practice, but you can do it. So now, let's not look at that one right now. Factoring by grouping. Factoring by grouping you do if you have 4 terms, which is kind of what we did on that last one. So what I want to do is this. I've got 4 terms. I want to put it in here, put it in here, put the first 2 in parentheses, second 2 in parentheses. So factor out what's in common. So that'll be 9x squared, and that's going to be x minus 3, plus 2x minus 3. So I'm just doing that greatest common factor stuff one more time. So that's 9x squared plus 2 times x minus 3. There's my answer. All right. Talk to me with questions. We're spending some time on this to get your factoring skills sharp. So spend some time with this practice, and for the love of math, check your work.